is the following. It causes the reaction to happen faster, but does it affect how much stuff is produced? No, it does not affect the amount of product made. Your sister just give up because her seat was taken?
No, she's on the Zoom.
She is on the Zoom? What?
Trying to get her.
Okay, well, tell her it's on now. I was late because I had to help try and get that computer to restart, but it never did. Oh, okay. Participants can now see my screen. Welcome. All right, so since a catalyst won't really affect how high this is and how high this is, it just helps it get there sooner. We actually say it has no effect on the equilibrium position, like none. Because, yeah, for sure, some application of it, yes. So where the concentration of products and reactants ends does not change. It will get there faster, but overall no change. All right, so equilibrium is achieved faster, but the equilibrium composition remains unaltered. So see how like it ended here either way? Yeah, I see it. Thank you. You guys bring your swimming stuff?
Yes.
Someone doesn't want to.
No, I brought sweet.
Okay, we're having an AP west side of the room swim party. Nope, we're not. Never mind. Not coming. Okay, just kidding. We're doing it for track. Okay, that's literally all you need to know is that catalysts do not affect the equilibrium position. That's it. Now, there's more you need to know about catalysts, but that was last chapter. Okay, I'll come back here in a minute. This is the final thing from this whole chapter that's new, and that is the effect. This has to do with the Chatelier's principle, sort of. It's the effect of adding an inert gas, which means one that does not react with the gases already in there. An inert gas, also known as a noble gas, such as helium, is one that does not react with other elements or compounds. Adding an inert gas into a gas phase equilibrium at constant volume does not result in a shift. Well, okay. Yep, it doesn't do anything. And the reason why, this goes back to chapter 10, which all of you loved, even though you failed the test. Chapter 10 said that the partial pressure of a gas is independent of the other gases there. That sound familiar? Yes, sir.
So a gas that doesn't react with anything doesn't do anything because it doesn't react with anything.
Pretty much. So there's no chemistry involved, and it doesn't change the partial pressure of the other parts. I forget this shirt and this microphone don't work very well. All right, there's more. This is because the addition of non-reactive gas does not change the partial pressures of the other gases in the container. While it is true the total pressure of the system increases, the total pressures does not have any effect on the equilibrium constant. Rather, it's a change in the partial pressures. And if you remember yesterday, the answer would say the partial pressure of NH3 increases or decreases. Remember that? It did say partial pressure. All right, yada, yada, moving on. If the volume was changed, then a problem or a change would happen. But an inert gas does not affect the equilibrium position. Okay, let me rearrange these. That should be there. Okay, questions? Let's just practice. Everything we practice has a chance of actually being the same one on the test. Now, not all of them are going to be on the test. Here we go. Whoops. Solid sodium hydrogen carbonate, NaHCO3, decomposes on heating according to the equation above. And then I don't feel like reading the rest of that, but I'm going to read it quietly and see what happens. Ooh, the number of moles present at equilibrium. That sounds pretty fun. Grams of the original solid remain under the conditions described. Write the equilibrium expression for that and that. Okay, this one's actually really hard, so let's do this one after some easier ones. Are you okay with that? We'll start easy and work our way up. Interesting. Russell Wilson might be a Denver Bronco. the Seahawks, Russell Wilson. Yeah. Oh, what? All right, give this one a shot. I'll go get more caffeine. If you guys borrow a calculator, will you get in the habit of putting it back? Right after this class, Burgraff comes in for whatever he teaches. So I just don't want them to screw around with my $120 calculators. Okay, do you still need time? All I hear is silence. Anyone need time? Raise your hands. Okay, that's a few of you. All right, I'm gonna keep going. Or sorry, I'm gonna start. You can keep going if you're still doing it. So I'm gonna put 2SO3, my arrow here, so I know my reactants and products, 2SO2 and O2. Initially, the vessel, who cares about the temperature as of right now? And SO3 is 0.5. Remember our initial, our change, our equilibrium. So 0.5, and does it say there's any of this? No, so I'll assume it's 0. SO3 is 0.2 here, correct? And then we're ready to go. So this change was a minus 0.3. We okay with that? This and this have the same coefficient, so the change would be equal but opposite signs, so positive 0.3. And this is 1/2. half of the other changes, so it's a positive 0.15. How many were able to get that? All right. So those of you that are not playing on your phone seem to got it pretty much perfect. So I have a 2 with 0.3. So I'm going to take 0.3 and I'm going to square it, right? And then I have a 0.15, and this is all on the numerator because the products are on top. And then I have a 2 with my 0.2, and I square that then. And I don't know, anybody know what that is? 0.3375. Okay, I feel pretty good about that. That is the KP. How come I know it's KP and not KC? Good, it gave me pressures. All right, if asked to, I could find KC just using the equation that they gave me. This is, yeah, you don't have to have that memorized. All right, that one wasn't too bad, hopefully. Who was able to successfully do that problem? Raise your hands. 1, 2, 3, 4, 5. Brown, sorry, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16. That is way smaller than I thought it would be. It's above average. Ooh, this one looks very good looking, except for the A, but we'll live. All right, nitrogen trichloride decomposes according to this at 400 degrees. Do you see how this is in bold? I'm guessing the temperature matters this time. If temperature matters, then probably what am I going to ask you to do? All right, yep, I'm going to have a KC and a KP, and you're going to have to convert them. Also, what do you notice about this red flag right here? All right, good. So it should be 673 Kelvin, right? Okay, I'll pause this for a while, see how it goes. Ooh, I like just reading this. Here we go. So we have this stuff, yada, yada, yada. How many moles are in the flask at equilibrium? So that's going to have to be an ice table, right? All right, so I have 2, this could, I'm going to thin this up. Here we go. 2 NCl3 arrow 3 Cl2 plus 1 N2. We have this much, and it says there's none of the others. That's convenient. 0.64 at initial change equilibrium. All right, 0, 0, plus sign, minus. You don't have to do that. I just do it sometimes, make sure I don't screw up. At equilibrium, 0.16 mole of N2 was present. All right, so 0.16, we okay with that?
Yep.
All right, so my change here, that's always nice when it's the 1. So the change was plus 0.16. This would be 0.48, right? And this would be 0.32. So I end up with 0.32, 0.48, and 0.16. Who can agree to that? Okay, so these would be the answers over here. This says moles right here. Is that what you were asking? Yeah. Oh, look out for my man, Tim. Okay, now, what is the value of Kc for this reaction? All right, are we ready? Kc is equal to the products, so Cl2 squared or cubed, right? Now, is everyone ready to get really annoyed? Bill, what were you saying? It is supposed to be concentration. So everything's divided by 2. Okay, Tim asks a great question. He says, why? It's
2 liters.
Kc is concentration. It's in a 2 liter. So I know. if you go way back in time, I foreshadowed this moment on a problem where I thought it would matter, but it didn't end up mattering. Do you remember that?
Yeah.
So this is, I'm sorry. It's okay. So 0.16 would be, yeah, 0.08. I'll just put all the halves. Do I need to square that? Nope, because it's just a 1. And the denominator would be 0.32 halves over, or sorry, not over, squared, right? Okay. It's rude. Who said they were right for the first time ever?
But I wasn't
Nice.
because I
Oh.
didn't do that part. That's what I was saying.
Sorry.
You know, that's not real.
Okay, I was, never mind.
We all got small numbers, but the number we were supposed to get was even smaller.
Probably. Did you divide them all in half, Bill?
Yeah.
Okay,
I got 0.04.
0.04. All right. What did you get if you didn't divide it in half?
0.172.
Okay, you can't, just math-wise, you can't just divide your answer in half. Like, it'd be nice, like, oh, I forgot to divide all those. No, because you're squaring, cubing, and not. If they were all ones, yeah, that worked, but. All right, 0.04. So lesson learned, right? That if the volume, listen, if the volume's not 1 and you're doing the math to find Kc, you have to find the concentrations. Now, if it's Kp, it will give you the ATMs and the volume doesn't matter. Like it's telling you the pressure. The volume doesn't matter in Kp. But this problem, it asks for Kc. Okay, so it's 0.04. So the value of Kp then would be equal to 0.04 times 0.0821 times 673. And that would be to the second, 4 minus 2, right? And I have no idea. What did this end up being? 131? It's all right. I think they said 0.8. Hey, and when you guys start getting in the habit of circling or boxing your answers, most of you do, but like a lot of you just pretend there's like a 0.73 here and like a 1.58. You just have all these numbers over here and I'd be like, oh, there's a 131 somewhere. Like circle your answer or put it in a box. Like AP used to say, put your answer in a box. And if you did not put your answer in a box, you would miss a point. They don't do that anymore. But anyway, okay, according to KC, because they're different, right? According to the value of Kc, is it product or reactant favored? Well, Kc is 0.04. That would mean I have a really small numerator and a large denominator, right? Which would mean it's what favored? It's reactant. Okay, and you can memorize that, or you can think, well, mathematically, if products are over reactants, what gives me a small number? It's when this is big and this is small. So it would be reactant favored. Okay, what is the total pressure inside the flask at equilibrium? Well, this is fun. This takes us to chapter 10, one of my top 2 of all time. Piv nerd. It's nRT over V, correct? So the N would be these. Do I have to divide them in half? Nope. So I add all these 0.96. That's all the moles left inside this container.
Okay.
And it was 0.96, correct? All right, times R times T, and all that will then be divided by the volume. And I don't know, pretty decent size number. Okay, not that huge, but still pretty big. Okay, no equilibrium required there besides just finding what the moles are at equilibrium. And you just add them all. I'm sorry. I heard some exasperated breathing back there. All right, letter E. If neon gas is added, what happens? Nothing.
Overall pressure.
Right. You would say the addition of
It looks like it's not like.
it says nothing. It says nothing.
It's a deformed little frowny face.
It's a Tom Davidson gets lazy. That's what it is.
Circle the.
Writing on this slate is not the easiest thing. It's recording. All right. So the addition of an inert gas does not affect the partial pressure of another gas. Or for this, you would say nitrogen. Are we okay with that? 0.73 was a number I just made up to say it's hard to find numbers sometimes in your answers. All right, we feel good about this problem? This, oh,
I
sweet.
just made one mistake.
Everybody else feel okay about it? This one is on the test.
So now next time we will never forget to check how many. If the volume.
Yeah, well,
Divide by volume.
I would like to believe that you guys would never do that again, but yeah, I'm just gonna, I love you guys.
Accept the fact that we never learned.
Yeah, I believe we've already done this one, have we?
This looks familiar.
Okay, sorry, we did the coal gasification process, which is very similar to this. You really want to? Okay, sweet. I will pause. So the mass action expression CO2, H2 over CO and H2O. Any of them raised to anything? Nope. So you get points for this. It should technically say Kc equals that. You'll get a point for that. Now, did anyone check my math? In this one, I don't think you have to divide by 3. Because they cancel each other out. You have a 3 in the denominator of the numerator and 3 in the denominator of the denominator. And so let's just nadir it. It gone. Okay. But that's only because these are ones. All right, so we can just plug crap in. We need the ice table, I guess, don't we? Okay, I'm going to delete that. I apologize. All right, we had CO, H2O, CO2, H2. Beautiful, Thomas. Initial, an experiment had, it had some stuff in more than just one box, 0.35, 0.4, and still these are at zeros, right? There was 0.19 right here. Okay, so my difference was, I swear we did this one before. Oh, I'm sure it happens. 0.24, right? All right, so all this turns into 0.16. I'm just going to square it, but not because the mass action, just because it's the same number twice. And I'm going to divide it by 0.19 times 0.24. And what did you get? 0.56. Are we okay with that? We agree? Okay. It didn't ask it, but product or reactant dominant? Reactant, because it's less than 1. All right. How do you find the number of grams of water? You take this and multiply it by 18. And that would be 2.25-ish, 2.5-ish, I mean? 4. Okay, I'm good. I'm sorry. 4 point what? Okay. All right, does everyone understand that last part?
Yeah.
To go from moles, or sorry, to find grams from equilibrium values, you just multiply by the molar mass. Okay.
Molar mass of water, H. 2.16.
So these are from the lab. I don't know. We'll be all right. Hey, there's what's his face.
Scrap.
Okay, here you go. This is Le Chatelier's principle question. What time are we out of here? 10 minutes? Okay, sweet. These are some holy mashed potatoes and gravy. Okay. Will you try these? Please. Start, I would resume recording. Then I would put the heat term. Where does it go? Left or right? It's left. It's endothermic. Okay, here we go. So everything we're talking about is how NH3 is affected. So if I add NH4Cl, I go away, which means NH4 does what? It increases. An increase in reactant causes an increase in product. The temperature of the system is increased. If we add heat, we go away from heat, which again is going towards the products. So we would say it increases again. Okay. Adding heat to an endothermic reaction causes more products to be formed. The volume of the system is increased. All right, AKA the pressure is doing what? The pressure is going down, right? Okay, in order to figure out this, I need to know the moles. I have 1 on this side, I have 2 on this side. Are we okay with that? All right, so if it's decreased, it goes to the side with the most. So once again, the NH3 would increase. So far, so good. All right, a quantity of HCl is added. Finally, we have a different answer. If I add, I go away. Moving away from the product towards reactants means that NH3 would decrease. All right, this is the one everyone's like, that's bullcrap, Davidson. A quantity of gaseous NH3 is added, causes NH3 to go down. Remember, we add, and that's the vertical line, so it's at equilibrium. We add, remember how the graph looked like this? But it's asking you what happens after you add, and it would come down. Whoa. Good, that was one of my better graphs.
Come down lower than it was before. So
Mm.
overall, but that's not what it's asking. That's not what it's asking.
I get what you're saying.
Yes, but no, you're right, but no.
I get it, but do you get my explanation? Because that's the one AP is going to expect. The pressure of the system is increased. All right, so we already did that, but it's the opposite.
Wait, I mean,
Oh, sorry. Yeah, that was the pressure. I'm sorry. This was the answer. So the opposite is down. Okay, a catalyst is added. What happens?
nothing.
Nothing. What was F? Okay, I made it confusing. So let's just ignore it. Pressure increases, so we would go away from the side with more moles or towards that size. So it would go down. Okay, I'm gonna call that good. I gotta end this. So
I gotta go grab clothes for skills for my